All right, so why does this rational function have a hole at 3 comma 1/7? So when you graph a rational function, first thing you want to do, whether it has a hole or not, is you want to simplify, or is you want to factor it. So we get f of x is equal to x minus 3 over x plus 4 times x minus 3. Now, if you think back to when we learned about rational functions earlier in the year, we learned that you could simplify them by like canceling out common factors. So if we did that, then f of x simplifies to 1 over x plus 4. So no matter, as long as you don't plug in 3, all right, if you plug in any number into this version of the graph, it's going to give you the same y value as if you plug in into that version of the graph where it's simplified. But if you do plug in 3 into here, you get undefined. But if you plug in 3 here, you get 1/7. So we kind of use the simplified version of the graph to see, well, what would f of x equal if it was defined at 3? Because this x minus 3 over x minus 3 is equal to 1 for every value of x other than 3. So like these two versions of f of x are the same exact graph except at 3, because x minus 3 over x minus 3 is equal to 1, except when x equals 3, it's going to be undefined. So that's why you cancel out the hole, or the common factor, and plug in that value to find the hole in the simplified version. So if we were graphing this, it would have the point like 3 comma 1/7, and we would just use that as like part of our graph, but just know that it's undefined there. Similar to an asymptote, but with an asymptote, since it's not a common factor in the numerator and the denominator, it's going to affect the graph much more drastically, like around that point, as opposed to if it's the same factor that cancels out, it's not going to really affect the graph other than at that one point. Does that make sense? No problem.